Welcome to the Magnetic Fields of Coils video. In this experiment, we'll be investigating the axial magnetic fields of single and multiple coils at different separations and measuring the permeability of free space.
Attach one of the coils to the base using the provided thumb screw. Attach the mounting brackets to the opposite corners of the track. Put the track through the coil and mount it on the two rods. Attach the rotary motion sensor's mounting bracket to the end of the track, making sure that it is perfectly vertical.
Mount the rotary motion sensor on its bracket and adjust it to a suitable height. Plug the sensor into the data acquisition interface. Also, attach a cable from the magnetic field sensor to the interface.
Estimate the position of the middle of the metal at each end of the coil and measure the distance between them. Record this as the diameter of the coil. If necessary, adjust the height of the track so that the tip of the sensor will pass through the center of the coil.
Move the apparatus such that the rotary motion sensor is hanging over the edge of the bench. Tie the provided string around the magnetic field sensor, attach the mast to it, and hang the string over the rotary motion sensor.
There are 3 pulley sizes on the rotary motion sensor. This experiment file has been set up assuming that you will use the middle one. As such, if you use a different pulley size, your position data will not be accurate.
Use the 2 banana cables to attach the signal generator from the data acquisition interface to the 2 terminals of the coil.
On the computer, go to Blackboard, download the capstone file, and open it in Capstone.
At the left side of the screen, click Data Summary and click the gear icon next to Rotary Motion Sensor. Move the magnetic field sensor to the center of the coil. Press the Tear button on the sensor and click Zero Sensor Now on the computer. You may now close the data summary.
At the left side, click Signal Generator. Ensure that the voltage is set to 15 volts and click On. Press Record and pull the magnetic field sensor through the coil. Make sure that the string turns the rotary motion sensor as you do this. If your graph has a minimum at the center, you will need to switch the terminals on the coil.
Also, if the peak of the curve isn't at the center, you may wish to adjust the position of the coil so that it's approximately in the center of the range of motion of the tip of the magnetic field sensor.
When the terminals are connected in the proper order and the coil is properly centered, a good single coil run should look something like this.
Next, we want to move the magnetic field sensor to the center of the coil. To do this, press Record and remove the mass from the sensor. Slide the sensor to the middle of the coil, watching the magnetic field display at the bottom left of the screen as you do so. When you find the maximum, stop moving the sensor and press Stop.
Now, we will record pairs of magnetic field strength and current data. Press Record and write down the 2 numbers in your notes. Lower the voltage, say by 1 volt, and repeat. Do this until you have 10 pairs of data.
Next, we will add the second coil. Remove the stands and disconnect the coil from the data acquisition interface. Attach the second coil using the provided thumb screw. Note that if you face the coil terminals away from each other, it will be convenient later. Put the track back through the coils and reattach the stand.
Like you did for the single coil, capture the axial magnetic field as a function of position. We will do this for 3 distinct coil separations, 1 equal to the coil radius, 1/2 of the coil radius, and 1.5 times the coil's radius. Note that you should click off on the signal generator, tear the magnetic field sensor, and turn on the signal generator between each run.
We hope you enjoyed the Magnetic Fields of Coils video, and remember, try not to get wound too tightly when writing your lab report.